LR parser. LR parsing is one type of bottom-up parsing. It is used to parse the large class of grammars. In the LR parsing, L stands for left to right scanning of input and R stands for constructing a rightmost derivation in reverse. K is the number of input symbols of the lookahead used to make number of parsing decision. So LR parsing is being subdivided into LR0 parser, SLR1 parser, LALR1 parser and CLR1 parser. So SLR is nothing but simple LR, LALR is look ahead LR and CLR is canonical LR. Here LR0 is the least powerful and CLR is the most powerful. So these are different types of LR parsers. The LR algorithm requires a stack, input, output and a parsing table. In all type of LR parsing, input, output and stack are same but parsing table is different. So in all these LR parsing tables, input, output and stack are same but the parsing table will be different. There is a slight difference in constructing the parsing table. So we need to consider a stack. In stack it is being inserted with a dollar and we are going to consider the input and output and we are going to construct the parsing table. Input buffer is used to indicate end of the input and it contains the string to be parsed followed by a dollar symbol. A stack is used to contain a sequence of grammar symbols with a dollar at the bottom of the stack. Parsing table is a two-dimensional array. It contains two parts, action part and go to part. So input buffer is nothing but we are going to take the whatever the input string we are needed to parse, that input string will take in the input buffer, and stack is nothing but whatever the sequence of grammar symbols are there that we are going to insert into the stack. And parsing table is a two-dimensional array. It contains action part and a go to part. So in that first one we are going to consider the LR0 parsing. So in LR0 parsing various steps are involved in parsing. For the given input string, the first we need to do is write the context-free grammar. And then next check ambiguity of the grammar. And then add argument production in the given grammar. And then create canonical collection of LR0 items. So for example, consider this S tends to AA and A tends to AA or B. Whenever we add one or more production, it is called as argument grammar or argument production. The use of this argument production is to identify when to stop the parser and announce the acceptance of the string. So what is argument production? So consider this, we have taken as S tends to AA, A tends to AA and A tends to B. So argument production is nothing but inserting one new production here, S dash tends to S. So this is called as the augmented production. And after writing the augmented production, we need to draw a data flow diagram and then construct LR0 parsing table. So with this example you will be clear. So consider the example S tends to AA, A tends to AA or B. So the first step is add the augmented production. So the augmented production is S dash tends to S, S tends to AA, A tends to AA or B. Next step is create canonical collection of LR0 items. And LR0 item is a production G with dot at the some position on the right hand side of the production. So LR0 items are nothing but we need to place a dot on the right hand side of the production. So S dash tends to dot S, S tends to dot AA, A tends to dot AA or dot B. So this is called as the LR0 items. LR0 items are nothing but placing a dot on the right hand side of the production, that is called as the LR0 items. LR0 items is useful to indicate that how much of the input has been scanned up to a given point in the process of parsing. In the LR0 we place the reduced node in the entire row. So next step is drawing a data flow diagram. So data flow diagram is nothing but first step, write all those, that is s dash tends to dot s tends to dot aa, and a tends to dot aa or dot b. So this we are considering as a state I naught. Now what you need to do is you need to perform the closure operations for this. That is nothing but this dot should be placed to the last of this production or rule. As this is placed to the right hand side of the starting at the starting symbol of the right hand side, before the starting symbol of the right hand side production, this dot is placed. So we need to, in this data flow diagram, we need to reduce this dot to the end of the symbol. Okay, so now on symbol s, so this can be reduced like what? S dash tends to s dot. This dot should be placed at the end of this right hand side production. Until then we need to reduce this. So this I am taking as state I1. And next, on state A, it becomes as s tends to, and we can shift the dot only towards only one symbol at a time. Okay, so it becomes as s tends to a dot, again a. So after dot, if there is a non-terminal, that non-terminal whatever productions we have, that we need to write in this state. So as a is a non-terminal, for a we are having the production like a tends to dot aa. So dot aa or dot b. So a tends to dot aa or dot b. That also you need to write here. So this is considered as state I2. And next, on symbol small a, it becomes as a tends to a dot a. So after a, after dot, we are having a non-terminal a. So this whatever the productions we have for capital A, that we need to write a tends to dot a tends to dot b. So this we are considering as state I3. Next, on symbol small b, so it becomes as a tends to b dot. So this I am writing as state I4. Okay, now the comes from the starting place, like now check this. I1, already the dot is placed to the last of this symbol. Next I2, so here before a there is a dot, so this you need to shift here. So on symbol a, it becomes as s tends to a dot. This I am writing as state I5. On symbol here, see here, on symbol small a, so after we do this, what it becomes? A tends to a dot a. So it is already there in state I3. So directly draw a transition to I3. Next, on B, A tends to B dot. So already it is there in state I4. So draw a transition to state I4. So this state is being completely completed. Now state I3. So here there is a dot here. This should be placed to the end. So on small a, if we done the transition, what it will become? A tends to a dot. So a tends to a dot. On a tends to a dot. This is done as a symbol. This is done as a state I6. Okay. Now consider this. So a tends to dot aa. The a should be placed to the last. So only one we can shift at a time. That is, now it will become a tends to a dot a. It is already there in the same state. So we are drawing a self transition to this and placing a. Okay. And next, a tends to dot b. So it becomes as a tends to b dot. It is there in state I4. So I am drawing a transition to state I4. Clear? So with this state is also being completed. So with this we have placed the dot to the end of the right hand side symbols. So this is called as the data flow diagram. Data flow diagram is nothing but the LR0 canonical items whatever we have taken, that is we have placed a dot before the starting symbol of the right hand side production. That dot we need to shift to the last, that is to the end of the right hand side symbol. That in that way you need to draw a data flow diagram. Okay, and the next one is you need to construct a LR0 parsing table. So in LR0 parsing table, we will consider these steps. If a state is going to some other state on a terminal, it is correspond to a shift or action move. See here, from one state to another state, if it is moving from one state to another state, that is I0 to I1, here it is moving, so it is called as a shift state or action state. If a state is going to some other state on a variable or a non-terminal, it is correspond to go to. If on a non-terminal, so these are the non-terminals, capital letters, that is uppercase letters. On a non-terminal, if it is shifting, it is called as go to. On terminals, if it is shifting, it is called as shift or action. On non-terminals, if we are moving, it is called as go to. If a state contains the final item in the particular row, then that is called as reduce node completed. So if a state contains any final node, any final item, so now see here, this is the final item, then there we can use reduce operation. So now you need to construct a parsing table. So here we have taken the states, action and go to. So in states, whatever the states we have in the data flow diagram, that you need to write, that is I0, I1, I2, I3, I4, I5 and I6. And in action, we need to write the terminals, and in go to you need to write the non-terminals. Okay, so in action we have taken the terminals like A, B and dollar, and in go to we have taken the non-terminals, that is A and S. So now check here, I0 on A, I0 on A, check from this data flow diagram, I0 on A. So I0 on A, to which state it is moving? I3. So here we need to write as shift 3. So here you need to write as shift 3, that is S3. As I told you, like on terminals, if it is moving, we will be using as shift operation. Okay. So now I0 on B, I0 on B, I0 on B, it is moving to state I4. So we need to write shift 4, I0 on B, we need to write shift 4. Next, I0 on capital A, I0 on capital A, I0 on capital A, it is moving to state I2. So on non-terminals, we will consider it as go to. So there we will write only the, we are going to write only the number, just 2. And I0 on S, I0 on S, I0 on S, it is moving to state I1. So just we are going to write 1 here. Clear? In the same way, from the table, that is from the data flow diagram, you need to check and write all these. Okay? So shift operation you understood, and next reduce operation is nothing but if that is the end of the state, then you need to write the reduce operation. So here I5, I4, I6, these are the final states. So final states, S tends to A tends to AA and A tends to B. So for this you need to assign the number starting from 1. Okay, these are called as reduced. Now S tends to AA is termed as R1, A tends to AA is reduced as R2 and A tends to B is reduced as R3. So with the help of this, after drawing this, we need to construct the, so see here, shift you understood, right? Now see here, I4 on A. See here, I4 on A. I4, where is this? I4 on A. So it is the last, that is where no more it is not moving to any state. That means here we can perform the reduce operation. So before doing the reduce, what we need to do? We need to consider this input production and assign numbers for this. See here, S tends to A tends to A tends to B. This is our given grammar. So for this, assign numbers 1, 2, 3. So now this is S tends to A is called as reduce 1, A tends to A is called as reduce 2, A tends to B is called as reduce 3, R3. Now I4 on small a. So I4 on small a, it is not moving anywhere. So what is the production here? A tends to B dot. So check the number here. A tends to B dot. So what is the number here? R3. So R3 should be placed in all these terminals here. R3, R3, R3. In the terminals A, B and dollar, R3 should be placed. Next, I5. So check I5 state. So I5 state is also the end state. Reduce operation should be performed here. S tends to AA dot. So check what is the number for S tends to AA. R1. Reduce 1. So here you need to place in all this terminals column R1, R1, R1. Next, I6. Check I6. I6 is also the end state. No more moves are being performed here. That is, I6 is not being shifted to any other place. Here it has been stopped. That means reduce operations should be performed. A tends to AA. Check the number here. A tends to AA. It is given as R2. So in place of all the terminals, R2 should be given. So this is called as the parsing table. Clear, no? In action we are going to use shift, and in go to directly the number you are going to write here. See, I2 on capital A. I2. See, state I2. I2 on capital A. It is moving to state I5. So you need not write this I. Directly write 5 in place of A here. So I2 on A. So directly we are writing 5. Next, I3 on capital A. I3 on capital A. I3 on capital A. It is moving to I6. So 6 you need to write here. So 6 we need to write here. So this is how we are going to construct the parsing table. Now you need to parse the input string. So you need to consider stack, input and action. So stack is dollar and the input string we have taken is AABB. And the actions we are going to perform here is shift and reduce. So starting we are going to consider with the state I0. We have considered from the state I0. So 0 we are going to insert into the stack. So $0, and after the input you need to place dollar. Now how we need to check the action? First, we need to shift. We need to start from shift. The first, from left to right, the scanning will be performed from left to right. So from the left, we are having the starting symbol as A. So now how we can do this operation? Check this. 0 on A. Check this. 0 on A. What we have here? S3. That is shift 3. So here you need to write as shift A3. Clear? $0 A3. So this A3 is being shifted here. So the remaining what we have? ABB dollar. Now again you need to check 3 on A. Check here in the grammar, in the table. 3 on A. 3 on A, what we have? The action shift 3. So again you need to write shift A3. So this A is being shifted again here. $0 A3 A3. Whatever is remaining we need to write here. BB dollar. Now again check this. 3 on B. 3 on B. So 3 on B, what you have here? Shift 4. So that is the action you need to write here. Shift. What we need to shift here? B. Shift B4. Okay, so B4 is being shifted here. Now 4 on B. Check here. 4 on B. Reduce 3. Reduce. You need to perform reduce operation. Reduce R3. In R3 what we have? A tends to B. A tends to B. So this B will be reduced with A. So B will be reduced with A. So here number we need to write now. That how we need to write? Check the before one. This 3 on A. 3 on A. Check here. 3 on A. What we have? 6. So 6 should be written here. Clear? Now 6 on B. 6 on B. 6 on B, what you have? 6 on B, R2. So in R2, what we have? A tends to AA. So reduce R2, A tends to AA. So this AA is reduced with capital A. So AA is reduced. This A is reduced with capital A. So the number what? How we can write this? We need to check with this backside one with this non-terminal. 3 on A. 3 on A. What we have? 6. So here you need to write 6. Now 6 on B. 6. Now what you need to do? This one is completed. And now 2 on B. 2 on B. 2 on B, what we have? Shift 4. So 2 on B, what we have? Shift 4. So shift B4. That what we need to shift here? B here. B4. Now 4 on dollar. 4 on dollar, what we have? R3. Reduce R3. A tends to B. So this B is reduced with A. And the number how we need to write? This 2 on A. 2 on A, what we have? 2 on capital A, 5. So 5 you need to write here. Now 5 on dollar. 5 on dollar, R1, reduce R1. Reduce R1, S tends to AA. So AA is being reduced with S. AA is being reduced with S. So now check 0 on S. 0 on S, 1. So you need to write 1 here. 1. So you need to write 1 here. Now 1 on dollar. 1 on dollar. Accept. So the action here is accept. So this is how we are going to parse the given input string. And then you need to construct the parse tree, that is S tends to AA, A tends to AA, A tends to AA, A tends to B. So we got the given input string AA, BB. So there is no need to get confused in this parsing the input string. First you need to consider the stack, input and then action. So stack, starting we need to consider dollar, and input take the given input string, and at the end of the input string consider as dollar. Now as the stack, that is the states we have considered from I0, that is 0th state we have considered. So into the stack first we are inserting 0. Clear? Now what you need to do, check with this with the input, that is 0 on A. You need to be clear with the table. If the table is clear, from this only you need to parse this input string. So now consider 0 on A. 0 on A. What we have here? S3. S is nothing but here shift. In place of that shift you need to write shift. What you need to shift here? This from this input, this first, only this first symbol, that is where the shift can be done from left to right. So only the first symbol can be shifted, that is A. This A can be shifted. A, and number what we have here? 3. So shift A3. A3 is been shifted here. Now again this, with this number you need to check with this input. Now 3 on A. 3 on A. Again shift 3. So like that you need to shift or reduce. Clear? In this way you are going to perform this